Hello guys, welcome to my YouTube channel. Myself Kirtan. Today I am going to explain about memory management. Let's see the outlook. First we're gonna see introduction and different types of memory management. Example for memory management. First we're gonna see introduction. Memory management is a crucial function of the operating system that is responsible for managing computer memory and allocating it to various process and applications. Memory management means managing the storage of the memory, where the memory data going to allocated, or where the data address, where it's going to placed. Next, the primary goal of the memory management is to ensure efficient utilization of the available memory resources, maximize performance, and provide a logical and isolated memory space for each running process. The main goal of the memory management is to store the memory efficiently or minimize the performance, and provide the logical and isolated memory space, providing the an efficient memory to the data. Computer memory, also known as RAM, random access memory, is a volatile form of storage that temporarily hold data and instruction that the CPU, central processing unit, needs to access quickly. RAM holds the memory temporarily, which the CPU going to access. When the CPU is in other instruction processing, the RAM will temporarily store the data which CPU is going to access later. Types of memory management: single contiguous memory management, partitioned memory management, paging, and segmentation. First, we're gonna see single contiguous memory management. Main memory usually divided into two parts. The contiguous memory is divided into two parts. Residential operations system usually holds the low memory. One is residential operating system, which holds the lower area memory. User process then held the higher memory. Next is user process, which held the higher memory. Each process contained in single contiguous selection of memory. Both processor are present in the single contiguous memory. Multiple partition allocation, variable partition schemes. There are different types of partitions. Whole of available memory. Holes of various sizes are scattered throughout the memory. In the diagram, we can see that space where the holes are scattered. Keep a table free memory. Holes means a free memory, which is keeps the memory freely. When a process arrives, it is allocated memory from a hole large enough to accommodate it. When a process accesses the hole, which hole will allow the data to access the memory. Process extinct free is partitioned, adjacent free partition combined. The process are divided and are going to combine according to the order. Operation system maintain information about allocating allocating partitions, free partitions. OS operating systems are will store the information of allocating partitions and free partitions. Next, we have partitioned memory management. Partitioned memory management is a memory management technique that divides the physical memory into fixed size or variable size partition to accommodate multiple process simulates. Partition memory will divide the data into two halves, which is fixed size and or variable size. It's the size is fixed for minimum, or it can be divided into equal of or not equal of, and multiple process and access the process simultaneously. Each partition is a separate block of memory that can be allocated to a processor, and partition can be equal or different size depending on the system configuration. The process gonna access each partition at a time. The partitioning of the data depends on the system configuration. whether it's gonna divide equal half or the not equal half. Next we have paging. Paging is a memory management technique used in modern computer system to implement virtual memory. Paging is used modern computer system to implement the virtual memories which cannot be seen. It provides a way to overcome the limitations of physical memory by dividing both the physical memory and logical or virtual memory. Paging will divide both the physical memory and logical memory into a fixed size block called paging. Paging allows process to use more memory than is physically available, enabling the system to handle large program and database. Paging allows the data to access more memory, which is physically lesser. It will allows the data to access more memory. It handles the larger program and databases. Paging provide memory protection by isolating the memory of each process from other. A process can only access its own virtual memory space, preventing unauthorized access or accidental interface. Paging provides the protection by isolating the memory, which can be accessed only by the virtual memory. Segmentation. Segmentation is another memory management technique used in a modern computer, often combined with the paging to provide a more flexible memory model. Uh, it's also used in the modern computers. It's a more advanced version of the paging. Unlike clip paging, which divides memory into fixed size blocks, segmentation divides memory into variable size logical blocks called segments. Paging only divides the only fixed blocks, but segment divides into variable parts, different types of parts. Each segment corresponds to distinct portion of a process address space and it's used to store related data or code. Each segment provides the data as well as the stored data stored address. So segment is more efficient than the paging. Segments allows process to have variable size segments which can adapt to the size of their specified data or code structure. Segments allows the data to variable segments which can data can be accessed very fastly and more efficiently. Managing variable size segments can reduce internal fragmentation and simplify memory allocation compared to fixed size paging. In paging, the memory allocation is more complicated, but in segmentation, the memory allocation is very easily simplified than the paging, and it reduces the internal fragmentations. And thank you for watching my video.